track the frequent street light malfunctions at College Chempaka Parking Lot, University Malaysia Sarawak, UNIMAS has created safety and security concern for both pedestrians and drivers. Poorly lit areas has caused incidents such as tripping, falls, and difficulty identify hazard, especially at night or during heavy rains. Analysis reveals that technical issues, various Sarawak humid climates, heavy rainfall, and a reactive maintenance system are the main contributors to the problem. The proposed solutions is a polar power motions activated modular lighting system which are reduce energy consumptions, lowers maintenance needs, and enhance overall safety and security. Implementing this system provide a practical, sustainable, and cost-effective ways to transform the parking lot into a well-lit, safer, and more secure environment.
Okay, my name is Muhammad Hamid Ibrahim, and my metric number is 105171. And then today I would like to present about leveraging trees to enhance campus life and operation at UNIMAS. Okay, so for the introduction, street lights are a crucial component of campus infrastructure as they ensure optimal visibility and safety for road users during nighttime. Proper lighting plays an important role in supporting pedestrian movement, vehicle navigation, and overall campus security. However, damaged street light at the College Parka parking lot have become an increasingly serious issue that requires urgent attention. The poor lighting condition make it difficult for individual to navigate the area safely, especially since the parking lot serves as one of the main pedestrian routes to the faculty. Insufficient lighting increase the risk of accidents and contribute to feelings of insecurity among pedestrians during nighttime. The purpose of this report is to analyze the issue related to damaged street light at the College Parka parking lot and to propose suitable solution to improve the lighting conditions. Ensuring proper illumination in the parking lot can help prevent accidents, reduce security risks, and enhance the overall experience of the road user. Okay, and then the problem analysis for this report is damaged street light around the College Parka parking lot at UNIMAS. Okay, for number one, identification of the problem. The malfunction street light at College Parka parking lot at University Malaysia Sarawak UNIMAS has become a growing concern to students, visitors, and road users. Based on the observation, all the street light at the parking lot is non-operational and result in poor visibility and increased risk to the road user. Number two, evidence and data supporting the problem. These pieces of evidence confirm that all the streetlights at the College Parka parking lot is not functioning during the observation period and have been out of service for an extended period. Based on the observation, there are multiple incidents such as pedestrian nearly tripping over the hole and parking divider, and there have been also cases where the driver struggling to identify if there is any obstacle around them because of the no light situation.
This is the methodology. First, the ideality. The parking lot must be perfectly illuminated only when pedestrians or drivers are present. The system should utilize zero external electricity from the UNIMAS grid and require no manual labor for maintenance. The solution achieves 100% safety and visibility while eliminating electricity bills and the needs for frequent technical repairs. This improves the current situation by shifting from a failing, high-cost infrastructure to a self-sufficient, invincible system that works perfectly without human intervention. Next, cost and effect chain analysis. The main problem is high risk of accidents and perceived insecurity in College Chempaka parking lot. Insufficient illumination and blackout zones during nighttime, the technical causes a large percentage of streetlights are non-functional due to bulb failure or circuit trips. Environmental causes high humidity and heavy rainfall in Sarawak, causing rapid corrosion of underground cables and short circuits. System roots cause reactive maintenance models that lacks real-time monitoring, leading to delayed repairs and prolonged darkness. Function analysis. The primary function of the current system, which is to provide light to the road user, is either non-existent or insufficient. The pole and enclosure are meant to protect the light source, but the wire is currently carrying out a harmful function by enabling moisture to generate short circuits, which affects the entire grid. According to the breakdown of the system components, by recognizing this failing interaction, we can determine that the system is not just suffering from aging, but also from a design that is unable to manage the link between the technical components, which is electrical current and the environment, rain and humidity. Next, the S-curve. The current lighting system, which uses conventional grid-tied bulbs, has reached the maturity or decline stage where performance is stagnant. Spot trends like more frequent failures, rising costs, or changes in energy use. To resolve the issue, UNIMAS must transition to a new different technological generation. Third one, function-oriented search, FOS. A function-oriented search was used to be searched at companies where dependable outdoor lighting is essential in high moisture areas to get ideas for a more durable system. For instance, the aerospace industry employs high durability lighting for landing strips, whereas the marine industry uses specialized non-corrosive materials and hermetically sealed LED units for offshore rigs. These areas offer an example of how Unimas could set up lighting at College Champaka that is especially designed to endure Sarawak's tropical climate. The fourth one, trimming. To increase system efficiency, we consider getting rid of the most problematic parts. All underground wiring and the centralized power transformer are removed and eliminating centralized dependency and no need for deep ground maintenance. Function analysis. The primary function of the current system, which is to provide light to the road user, is either non-existent or insufficient. The pole and enclosure are meant to protect the light source, but the wire is currently carrying out a harmful function by enabling moisture to generate short circuits, which affects the entire grid. According to the breakdown of the system components, by recognizing this failing interaction, we can determine that the system is not just suffering from aging, but also from a design that is unable to manage the link between the technical components, which is electrical current and the environment, rain and humidity. Next, the S-curve. The current lighting system, which uses conventional grid-tied bulbs, has reached the maturity or decline stage where performance is stagnant. Spot trends like more frequent failures, rising costs, or changes in energy use. To resolve the issue, Unimas must transition to a new different technological generation. The third one, function-oriented search, FOS. A function-oriented search was used to be searched at companies where dependable outdoor lighting is essential in high moisture areas to get ideas for a more durable system. For instance, the aerospace industry employs high durability lighting for landing strips, whereas the marine industry uses specialized non-corrosive materials and hermetically sealed LED units for offshore rigs. These areas offer an example of how Unimas could set up lighting at College Champaka that is especially designed to endure Sarawak's tropical climate. The fourth one, trimming. To increase system efficiency, we consider getting rid of the most problematic parts. All underground wiring and the centralized power transformer are removed and eliminating centralized dependency and no need for deep ground maintenance.
Hi, my name is Muhammad Rafiq Hakimi bin Muhammad Radzi. I hold the matrix number 108218 and I am here to discuss about our proposed solution. So as you can see, there is a sketch design of the lamppost that we made, a realistic design, and a 3D diagram prototype of the lamppost. Coming up, we have components. So the first component is a solar panel. So a solar panel functions by turning sunlight into electricity. After that, we have battery solar. So this is to store energy from the solar panel so that we can supply electricity longer. After that, we have LED lights. So we will use bright LED lights to, and make it replaceable in case it is damaged and needs to be replaced. After that, we have waterproof casings. This is to protect the electrical components from rain or any damage that could be done by water. Next up, we have motion detector. So the use of the motion detector is to control the electricity consumption by the lamppost. After that, we have a photoelectric sensor. This is to turn on the lamp when the environment is getting dark. And the lamppost is to support the solar panel and the lamp. So it must be rust resistant and it must be able to support the lamp in any conditions, whether it's windy, rainy, or sunny, and many more. And lastly, we have the cable. So we need to use a high quality cable so that the electricity can be transferred more efficiently and the cable will not be damaged easily.
Evaluation and discussion. For cost, higher initial investment is needs for the component, but then it can eliminate the electricity bills and reduce the maintenance costs. Modular units allow stage installation so can managing costs effectively. For sustainability, motions activated LED and solar power reduce energy use and the carbon footprint. High quality, waterproof, rust resistant material can suit for the tropical weather. Independent modular units extend system longevity and reduce maintenance needs. Feasibility, its units operates autonomously, reducing reliance on the power grids. Motions as photoelectric sensors are readily available and compatible. Replacement components simplifies the maintenance without affecting other units. For impacts on university community, it enhances the safety and security for students and staff, and then consistent and convenient lighting in pedestrian areas. Modular design simplifies the maintenance and management of sensor or battery issue.
Okay, so from the conclusions, our trace analysis revealed this problem was not just a simple maintenance issue, but it was become the systematic one. So here's we found some solution for fixing this problem. This can become a strategy upgrade, so such as replacing the old and reactive system with autonomous and also the solar power LED lights. So there can be 3 key outcomes for within this report. So first one is immediate safety. So it means like reliable illuminations makes the parking lots become more safer. Okay, and then the second one is long-term resilience. It means that like weather resistant, avoid from the raining and also the humid weather in Sarawak. So off-grid lights and frequency breakdowns. And then the third one, also the last one, is smart efficiency. It can match like on motion sensor and ensure the lights is provided when only need. So it can saving the electrical energy. So in summary, this transforms a chronic problems into a model of sustainable smart infrastructure for Unimas. So that's all. Thank you.